to Hanover Fair 2014. Welcome to the group exhibit Hydrogen Fuel Cells and Batteries. We are here at the Technical Forum. I invite you all to have a seat, lay back, enjoy the discussion. There will be lovely ladies walking around serving you drinks. The upcoming topic will be overpressure and hydrogen compressors dedicated to fuel cells. For that, please welcome with me on stage Innovation, Research and Development and Industrialization Manager from Busch Clean Air, Dr. Yohann Perrot.
Okay, so thank you very much for your nice introduction. So the main topic of my discussion today will be about overpressure technologies and regarding fuel cells. So not only for as an air compressor, but also as an hydrogen recirculation blowers. So to the next slide, please. Yeah, so this is my agenda. So first of all, I will speak briefly about the company I'm working for. And this is the name of Busch Clean Air. And then we'll speak about the environmental context for fuel cells. And also we will describe here our compressors as well as the hydrogen recirculation blowers. And finally, I will conclude with my outcome. So Busch Clean Air itself at first. So it's actually a part of a group which name is Busch, and Busch is a family-owned company established since 1963. So last year we have celebrated our 50th anniversary, so it is a great celebration. So Busch itself overall, so worldwide, so it's 2,600 employees separated into production plants and sales companies and service. So regarding the locations, you can see on the picture, it's really established worldwide, so in all continents. And the headquarter is located in Germany. It is not so far from here, about 4 or 5 hours in the southwest of Germany, in the region of Lorraine. And we have also 6 overall production plants. So we have, of course, in Germany, where the headquarter is located, but also in Switzerland, where we are coming from, United States, Great Britain, Czech Republic, as well as South Korea. Next slide, please. Thank you. So here you have pictures regarding different factories. So you have here 3 examples. Was the headquarter at first. So located, as I said before, in Marburg, in the southwest of Germany, close to the Swiss border. It's also where the families establish their own houses. It's on the left side of the picture, actually. You have also at the bottom left here our sister company in Chevenay, so it's also close to the French border. And on the bottom right, so you have a picture regarding our manufacturing company in Virginia Beach, United States. So now regarding Busch Clean Air itself. So Busch Clean Air is still today a startup. So we are 20 employees. Half of them are dedicated to the production and the second half to the support. So all the management support actually. So we have been established since 2010 and it's dedicated at first to mobile applications. So that's the aim of that company, compared to the Busch Group, who is specialized in vacuum pump and systems for the industry. So the current production capacity is about 30,000 air compressors per year, and we have already produced some parts for Deutz. So we speak about production of 12,000 parts per year, and we are currently in development for other OEMs. So from our side, we are located in Switzerland, very close to our sister company where you saw the picture on the slide before. And so we are located in the city is called Perrot. If you know, it's about 1 hour far from Basel, so south from Basel. And actually, so it's a nice place in the countryside, as you can see here. Okay, how about the people themselves? So what we are actually expert is about automotive industries. The reason for building such a new startup for the Busch Group was to be able to provide compressors for the automotive industry, but not only the automotive industry, but also for the mobile applications, meaning that could be also applied for train, ships, or airplanes, or whatever. But we are also very interested in stationary applications, since we might use our pump also as compressor or as a vacuum pump for the industry. So ourselves, we are highly skilled for production and assembly, because this is also the main characteristic of Switzerland, the precision. So it's really the key factor. And for the production of our products, you will see later on, we speak about hundreds of millimeters for the clearances. So it's very, very precise technology. Since we are also dedicated to automotive industries, we also respect and we are using some automotive processes such as the APQP, so the Advanced Products Quality Planning. The aim is really to get all the quality issues early in the development phase to be able to provide products with a high quality levels, and also to respect the requirements from our customers who are dealing with automotive products. We also have the power of the Busch Group behind us, because we are a member of that group. So when we need our support in terms of development, production, or even some managing support, such as the human resources, they are just behind us. So it's not only an autonomous startup, there is also a group behind. About the main advantage of being a startup is we are very flexible, meaning that when we receive some requirements from customers, actually we have the power to react and to give answers very quickly afterwards, and even to provide some prototypes very fast. Next slide, please. So now I just would like to speak about the environmental context regarding fuel cells. So I will just give here some examples dedicated to automotive applications, but it's also the same case for the industry or for the domestic applications as well. As you might know, since 2009, actually, the G8 members, they are all now focusing on the CO2 reduction to limit the global warming on the Earth. The main target is really to be under the 2 degrees C, and that will make, let's say, the level safe regarding the global warming, to avoid any ice fusion in the Arctic or in the Antarctic. And what does that mean to be under the safe 2 degrees C? It means that we will need to get a decarbonization of about 80% by 2050. And to do so, actually, all sectors who are responsible for the global warming must act in that direction. And if we take the example of the automotive industry, actually, it means that we might reduce CO2 emission by about 95%, which is really, really tough, actually. But it's not impossible, since when we speak about emissions control, it's already the situation for particulate matters or for NOx that we have already reduced by 95% both for passenger cars. So it means that it's not impossible. But to do so, there are many axes and many levers. First one is to improve the current applications on the current engines. And that could be, for example, by using alternative fuels, or by improving the engines themselves, or even by the hybridizations. But to reach 95%, we have to go forward. And for that reason, fuel cells might be a very good solution, since the emissions, the raw emissions from CO2 is neutral. And for that reason, that's one way that must be developed in the future, to keep at the same time the flexibility of using a car, whatever you want to do, so not only in city but also for urban or for extra urban use. And you can also at the same time have the flexibility to be able to use a car whenever you want. So not only that you have to pay attention if I have plugged my car yesterday evening, if I'm using batteries, for example, but it's really you have your tank of hydrogen, and you have your autonomy, and you know that you can fill your tank later on in a gas station as you are filling your tank right now with your traditional or usual passenger cars. Yeah. So in that frame, what we'd like to propose is some products, and we are not actually fuel cell makers, but we would like to provide products that will help the fuel cell makers to be as efficient as they would like to achieve. And to do so, actually, so we are developing compressor with a high performance one. And main idea at least is to reach the efficiency that OEMs want to achieve. So to give you a brief presentation regarding the product and starting with the air compressors, we can start with that kind of product which is called the Ming technology. So it's a family, it's a name given to that kind of product. It is based on the technology rotary claw. Actually, it's very close to a roots compressor, but it with a specific shape. So you will see on the next slide what it looks like. Main characteristics are the one which are directly asked or required by the fuel cell makers, meaning that it must be dry running, so no oil to avoid any pollution of the stack, and friction free as well, so to avoid producing some particles to the stack as well. It's also high efficiency. I will show you also afterwards that our target is to reach about 8% of the fuel stack power in terms of power consumption for our compressor. We also must achieve a very low pressure fluctuation to get a stable pressure signal to the stack as well. We ensure also a long lifetime, so we speak about 15,000 operating hours. And over the lifetime, it must be maintenance free so as to give the maximum flexibility to the end user and to avoid any costing maintenance. So of course, since it's for fuel cell, it must be ATEX compliant, so because it is like an explosive atmosphere, because we have at the same time hydrogen and oxygen coming from the air. And regarding the specific features for mobile applications this time, so it's one system, so it means that on the pump you have the compressor stage, we have the synchronization, the motor, and the electronics behind. So today the current product in the Ming family can be can run with 12 volt or 24 volt DC. It's a very stable product in terms of speed control, because what you give as an input is a speed level you want to reach to get a given volume flow rate at a given back pressure. And for example, if you are using a 24 volt version, actually it is stable between 16 volt and 32 volts, meaning that whatever the voltage amplitude you might have at the stack outlet, it is very stable at the pump because we have like a voltage stabilization inside of the electronics directly integrated thanks to a capacitor. It's using for that case a CAN communication that is also very useful in mobile applications, such as for trucks, buses or passenger cars. It might be used also in a large ambient temperature range, so we speak about minus 40 degrees C up to plus 85 degrees C, so which is also classical in mobile applications. Also in a vibrating environment, and it's also very flexible in terms of speed regulation, in terms of volume flow that the pumps can deliver, since it can work between minus 1000 meters up to plus 4000 meters. And also it's thanks to the electronics behind that really take into account the information coming from the mass flow sensor to be able to let it work whatever the air density. And of course it's also IP protected, so in that case it's 67 minimum. And most of our products are 69, so 6K, 9K. Yeah. So this is a working principle. If you just click on the picture, please. Yeah. And do you get the animation? Okay, so waiting for the animation so we can go on at least by explaining you about the design itself. So as I told you before, it really looks like actually a roots, but it is with a specific shape. And this is the shape here we are calling claw. And this is a patented design. from the Busch group, and actually that design enables us to get an internal compression with a pressure ratio from 1.2 to 1 compared to a standard woods who has no internal compression. Actually, the main principle is that here we have the air inlet, and we transport actually the air in 2 chambers before coming to the outlet where the air will be compressed. Okay, we can go to the next slide then. So here you have an overview of the products we currently have, and the product also you can see at our booth. So we have 3 different kind of products. The first one is the smallest one. It's today at a B sample phase, meaning that we have fully validated the product, and it will be in serial application at 24 volts this year, so in September. Main parameters are about the application behind. So as a air supply, it can be used for a 1 kilowatt fuel cell. And as you can see here, its maximum power consumption is 100 watts, so meaning that we can achieve a power consumption with that pump of maximum 10% of the fuel stack power. So as mentioned, also we can control it here either with CAN or, in that case, with PWM. And important are also the points regarding the lifetime, regarding the ambient temperature range, as well as the ATEX compatibility today. And our target is to be certified by the TÜV for that kind of family products to let them transport either air or hydrogen later on. Another point, so it's the middle one. This is the most interesting one because it's really on shelves, ready to be supplied, and either for air or hydrogen. And I will speak about that later on. You have here the performance, and regarding air supply, it will be for a fuel stack power of maximum 5 kilowatts in that case. And the biggest one, actually, it's also completely validated and ready to be industrialized. And this air compressor will be for a fuel stack power of maximum 15 kilowatts. Next slide, please. So with that kind of technology, actually, we can go up to 15 kilowatts. Very important for fuel cell is really the power consumption. So we speak about 8%, and for the smallest one, so we would like also to improve it to reduce from 10% to 8% of the fuel stack power, which is really the target today. And I gave you here an example of the medium-sized one. So for a 5 kilowatt fuel cell, we have achieved a maximum power consumption of 400 watts. And then to go further, we can use another kind of products. The main idea here is to propose a product as a demonstrator, and it will be, let's say, an intermediate step to another kind of family we will speak later on. So this one is a roots compressor. So it's a standard design for roots, and actually can be applied today for a fuel stack power of maximum 30 kilowatts. We have already the same kind of performance in terms of maintenance-free, lifetime, and also it's oil-free. So we have the same advantages as with the Mink, actually. Temperature range is a bit lower. It's a bit lower because this product must be improved for higher temperature ranges. So today it's only validated between -20 up to +60 degrees C. And it's a pretty light product, and it's today 2.8 kilo. As you can see on the picture today, it's belt-driven product, and we are currently working with our supplier to design the corresponding electrical motor to drive it with an electrical motor, so that it can be ready as a demonstrator within this year. So as I told you, this product, so the roots one, is an intermediate step before going into that direction. And that's really the promising technology for mobile applications afterwards. It is based on the radial compressor technology, actually. And the current demonstrator that is in development with our partner in Switzerland, which name is Fischer, can go today up to 50 kilowatt fuel stack power. Main idea is to develop that kind of technology to go to up to 150 kilowatts. That's really the target where we have heard also from our visitors till now. The main the main advantage of that product is really the air bearing. So there is no oil at all, and there's no need to cool the system down. So that's the key point of that technology. Besides, another point is that the rotation speed is also much higher, because to reach high volume flow rate with that technology, you must go up to 150,000 RPM or even higher. And it is the case today. Efficiency is also very high, so we speak about 75% that case, and it's a very robust and compact product. The current electrical motors can be run with a 400 volt DC system power, and it's also very compact because we speak about a pump about 25 centimeter long and about 10 centimeter diameter. Back again, and the next step for that technology will be to integrate the electronics, which is today completely separated from the pump. So that was about the air compressors themselves. And now if we can speak about the hydrogen, actually we have made like a carryover of an existing product. So you have seen before the Ming technology, so rotary claw-based technology. And actually we have just updated the product to make it compliant to hydrogen. And the main target was the tightness at first. Because hydrogen, the molecule is much smaller than for the air. As a consequence, even the material must be tight. For that reason, we have applied a specific anodization, so anodic oxidization of the aluminum to make the material completely tight to hydrogen. We have inserted also an O-ring because we have an interface between the cylinder and the gear housing to make also the system tight, and it has been tested over more than 1,000 operating hours at our partner Proton Motor Fuel Cell GmbH, which has also a booth here. It has worked without any loss of performance, without any degradation of the stack itself, and of course with a high performance. So I will show you that on the next slide. But if you can come back just before. Yeah, just before that. So tightness was the first issue. Second issue and second challenge for us was also the deionized water. So during the purification of the stack, actually a lot of water coming from the transformation of hydrogen and oxygen together is transported towards the pump despite the water separator. And actually to avoid any corrosion due to the presence of water and a high temperature at the same time, we've put a protection on the shafts themselves also to avoid any corrosion and to avoid any jamming of the compressor. And is also, so if you go on the next slide, so all of them combined, so those key issues were let's say overpassed, and thanks to the coating we have applied and thanks to the corrosion protection we have applied, actually we have let that pump run of about 1,000 or during about 1,000 operating hours at our customers. The efficiency is very high, so we speak about 0.7% of the fuel stack power for the hydrogen recirculation, which is really lower than what our customer expected actually. And as I mentioned before, we have experienced no tightness issue. Actually, close to the compressors there is an hydrogen sensor, and the hydrogen sensor didn't detect any hydrogen leakage at all. And finally, so against the humidity, we had no corrosion, and the protection we have applied were very successful. So as an outcome for that presentation, for that discussion also, so below 15 kilowatt, actually we have already some products on shelves. So that's really with a high efficiency that also we can discuss later on together. When we speak about fuel cells, also we speak about a lifetime. Most of our products today can achieve with guarantee 15,000 operating hours, which is actually for some applications much more than the stack lifetime itself. The different kind of technology, if we speak about short-term applications, actually routes can be applied as a product on shelves up to 30 kilowatts. But if you think about high power fuel cells up to 150 kilowatts, then we might think about changing the technology. And in that case, the radial compressor should be the most indicated one, since for that kind of applications, you have at the same time the compactness, low noise, long lifetime, high efficiency, and you got all of them in something that is completely new in terms of product design, especially regarding the bearing. So meaning that for that kind of technology, no water cooling is necessary. There is no oil cooling as well, so it's completely autonomous product. Regarding hydrogen recirculation, we have also some product on shelves. The efficiency as well as the reliability of the product have been demonstrated. And actually the only point now is to go further in terms of tests, because 1,000 operating hours is not sufficient now. So the pump is still living and will go on up to 2,000 operating hours, and then we will make an analysis. And the idea is to go up to the maximum operating hours that we can achieve with the air compressor, so meaning 15,000 operating hours with hydrogen. With that, I think I have finished my presentation and I'm ready to answer your question if you have any.
Thank you very much for this informative and very interesting presentation here right now. So, are here any questions right now here in the audience? So, not yet, I think, but as usual, often questions and problems are coming a little bit later in the mind. So please do not hesitate and come and visit the booth here. It's written D70 here at the group exhibit Hydrogen Fuel Cells and Batteries. I think you and your colleagues are invited, all of you. Okay. Thank you very much for your attention, and we have a little break now. After this we will continue our program with another very interesting topic. It's high temperature PEM basic reformed methanol fuel cells. Thank you very much.